Welcome to another video, and I have some solved problem still on the word problem here, and let's just run through it. The first one is if a number is increased by 30, it is less than its square by 12. Find the number. So I take the number to be x. Increasing x by 30, it should be less than its square by 12. So solving this or rearranging, I will get this x squared minus x, then minus 30 minus 12 being equal to 0, and this is a quadratic. So x squared minus 30, the solution to minus 30 negative 12 is still negative 42 being equal to 0. And now this is where the trick plays. You can solve it either by the quadratic formula or by factorization, which I just did here. And if solving it by factorization, I will have to take this last term here, which is negative 42, multiplied by the first term, which is x squared, gives me 42 x squared. And I have to think of two numbers which, when multiplied together, will give me this, and when added together will give me the middle term here, negative x. And those two numbers are 6x and negative 7x. So if we multiply these two numbers together, we have negative 42x squared. And when we add them together, we definitely have our negative x here. So I'll just take these two numbers and I replace it here. Instead of putting negative x, I put the numbers that I've gotten and I just factor. So all I'll have here is x in bracket x plus 6, then here negative 7 in bracket x plus 6. Just copy the bracket here and put it here. It's still the same thing. So if you do it the other way around, you get the answer to be the same, like x times x squared, then x multiplied by 6x, negative 7 multiplied by x, negative 7x, negative 7 multiplied by 6, negative 42. And from here, we just take the x minus 7 term and take one of these. So we are done. X is equal to 7. X minus 7 is equal to 0, which is the same thing as x equal to 7. Then x plus 6 equal to 0, which is x equal to minus 6. Now, how are we sure this is correct? If we take this value, which is the positive 7 here, and add it to this place, you will get 37. And 37 is smaller by 12 to 7 square, which is 49. So if you do 49 minus 37, you get 12. So that shows that we are correct. So the second one is the figure below shows an equilateral triangle with length of its sides given in terms of x and y. Find the value of x and y. Okay, now the best way I visualize this is not to solve by area or perimeter. Just since it is an equilateral triangle, this side must be equal to this side and still equal to this side. So I take this side to be A. That's why I said A is equal to B and is equal to C, since the triangle is an equilateral triangle. Then I solve. I already know my A from here, that A is 3y centimeter, while B is this term here, and C is this term here, 4x centimeter. So solving, I will have I just this my own technique of solving it, which makes it more easier to visualize. A is equal to B, equation 1, A equal to C, equation 2, then B equal to C, equation 3. So my A here is 3y, then my B here is x plus y plus 5. And if I add y to both sides, add negative y to both sides, I'll have my 3y minus y to be 2y. Then the negative y added to this side cancels the positive y, leaving me with x plus 5. So that's my equation 1. Then my equation 2 says A is equal to B, which is 3y is equal to 4x. Rather, A is equal to C, 3y is equal to 4x. So making y subject of formula, I will say I'll have that y is equal to 4x over 3. I call that 2i. Then I move to the last one here, which is my equation 3. B equal to C. My B is x plus y plus 3 and my C is 4x. So if I add the negative x term to both sides, x cancels x, leaving me with y plus 3. Then adding negative x to this side, I have 4x minus 3, 4x minus x rather, giving me positive 3x. That's my equation 3. Now, if I put this equation 2i into 1 or 3, now it's easier to work with this equation since I've gotten a value for y. So putting it into any of the equation, either 1 or 3. So I chose to put it in equation 1 here. You can put it in equation 3, you still get the same answer. Then I solve by opening the bracket 2 times 4, giving me 8. Then multiplying through by 3. The 3 cancels this 3, and the 3 multiplies this other right hand side to be 3x, and 3 times 5, 15. Solving, I will have my x to be equal to 3. Now, if I take this, my 3, and impute it in this equation 2i, you see that 3 cancels out, and I'll have my y to be 4. And that is the answer. Then the third one here is very easy, straightforward. The perimeter of a rectangular farm is 10 kilometer. Its length is 1.5 times its breadth. Now, take note of this. Its length is 1.5 times its breadth. Find the length and the breadth of the farm. Now, another way to write 1.5 is 3 over 2. And we already know that the perimeter of a rectangle is 2 open bracket L plus B, which is length plus breadth. Now, we have been given that the length is 3 halves the breadth. If I take the breadth as x, so the length is 3 half the breadth x, and my perimeter is 10. So this is equal to this. I will just replace my perimeter to 10, my 2. Then the length here, which is 3 half the breadth, I'll put it here, and the breadth here, which is x, I put it here. Then I will solve. This is a linear equation. Then I will solve by opening the bracket. 2 cancels 2, then 2 times x, 2x. And I have my answer to be x equal to 2 kilometer. Now, this x here is the answer for the breadth. What about the length? If I take my x and put it here, the 2 cancels out these 2, leaving my length to be 3 kilometers. Now, if you impute 2 and 3 kilometers into this equation, we will get our perimeter to be 10. That means we are correct. Now, the last question for this video is this. If 1 is added to the numerator and to the denominator of a fraction, the fraction becomes 3 over 4. That's one statement. Another statement goes like this. If 3 is added to the numerator and to the denominator, the fraction becomes 4 over 5. That is another statement. So we are asked to find the fraction. So from here, we take it step by step. I did it, both sides, but I'm going to explain how I did it. So if I add 1 to the numerator and I add 1 to the denominator, I will have 3 over 4, just as it is stated in this question. Then if I add 3 to the numerator, I don't know my numerator, I don't know my denominator, so I take it as x and y. If I add 3 to the numerator and add 3 to the denominator, the fraction becomes 4 over 5. Now, if I cross multiply my 4 multiplied by this term here and my y plus 1 multiplied by 3 here, I will have this equation here. this simplified equation. So I open the bracket 4 times x, 4x, 4 times 1, 4, 3 times y, 3y, 3 times 1, 3. Then solving, I will have this equation here, 4x minus 3y equal to negative 1. That's my equation 1. Then for the second part, I do the same thing and open the bracket, 5x, 5 times x, 5x, 5 multiplied by 3, 15, 4 multiplied by y, 4y, and 4 multiplied by 3, 12 here. So rearranging and solving, I'll have my 5x is equal to 4y being equal, 5x minus 4y equal to negative 3. And that's my equation 2. These equations can be solved simultaneously using the method of substitution. And here you see I brought it down, my equation 1, and here my equation 2. So if I solve by substitution, I pick my equation 1, let's see from here, I say from equation 1, 4x rather is equal to 3y minus 1. All I did was to move my negative 3 above the equality sign becomes positive 3y, or you can do it the other way, adding a positive 3y to both sides, so that the positive 3y in this left hand side cancels out and we have positive 3y negative 1 here. So it's just a simple step there. And making x subject of formula, I will have my x is equal to 3y minus 1 over 4. Now if I call this equation 3, if I impute this equation 3 into equation 1, mind you, you can't impute this equation 3 rather into equation 2. You can't put it into equation 1 because it was equation 1 that formed the equation 3, and that's why you cannot impute it back to equation 1. So you impute it to the second equation, which is equation 2. So if I impute my equation 3 into equation 2, I will have this equation here, 5 open bracket 3y minus 1 over 4 close bracket minus 4y equal to negative 3. Now if I open the bracket, 5 times 3y, I'll have my 15y here. Then 5 times negative 1, I will have my negative 5 here over 4. So these and these are basically the same thing. Either you separate the 4 or you add them together as a single 4, just like I did here. So they are still the same thing. Now if I multiply both sides by 4, that is the left hand side and the right hand side, I will definitely have a 15y minus 5 minus 16y being equal to negative 12. Now if I rearrange this and subtract, I will have my y being equal to 7. So this is the value for y. Now I can impute in my equation 1. I was not allowed to do it the first time, but now I can do it, or still impute in this equation 2. Either way, it's fine. So imputing the value for y into equation 1, I have my equation 1 written here. So this is equation 1, right? So my figure 1 written here. So I put my value for y. My value for y is 7. Putting it here, I will have negative 3 times 7 to become negative 21. My 4x is still here, and my negative 1 is here. So if I add 20, positive 20, 21 rather, to both sides, my positive 21 cancel out, and positive 21, negative 21 gives me my value of 20. Sorry, positive 21 and negative 1 gives me my value of 20. So solving for x, I'll have that 20 divided by 4 equal to 5. So this is not the answer. The question is find the fraction. So the fraction is x over y, which is 5 over 7. So our answer is 5 over 7. Now, if this video was helpful, give it a thumbs up and subscribe for more videos. More word problem and solutions are still coming. Thank you. Goodbye, guys.